Hello everyone, today we're going to set up a PHP project with Docker. First, we will create a new directory named blog. In it, we'll create a docker-compose.yml file. In this file, we are going to add two services, web and DB. The web service will use the PHP Apache image. This image gives us an Apache server that's already set up with PHP. Now, let's go to Docker Hub, where all Docker images are stored. On the PHP image page, we can see many tags for PHP. One of them is PHP Apache. This image combines a PHP runtime with an Apache server. With this in mind, let's build our Docker Compose file for the web container. The version 3 at the top of the file indicates the version of the Docker Compose file format that you're using. Each version of Docker Compose's file format adds, removes, or changes functionality compared to previous versions. Therefore, it's important to specify the version you're using, so Docker Compose knows which features it can expect in the file. The web service is our web server. We're using the PHP Apache image, which gives us a PHP environment running on an Apache server. This image is pulled from Docker Hub, a cloud-based registry service that allows us to distribute Docker images. The volumes directive under the web service is /var/www/html/. Here, the / represents the current directory on our host machine, and /var/www/html/ is the default directory where Apache looks for files to serve on the container. This configuration means that our application's codebase in the current directory is made available to the web server in the Docker container. The ports directive is set to 80:80. This means that port 80 on the host is mapped to port 80 in the container, which is where Apache listens by default. However, you have the flexibility to change this. For instance, if you want your server to listen on port 8080, you can change the directive to 80:80:80. We also need a database service. For this, we'll use the MySQL image. Let's take a look at MySQL's page on Docker Hub. Let's add a database container to our Docker Compose file using the latest MySQL image. We're using the MySQL latest image. Like the PHP Apache image, this is pulled from Docker Hub. The volumes directive for the DB service is db:/var/lib/mysql/. This creates a named volume DB which is stored in a Docker managed portion of the host file system. All database data will be stored here, ensuring that it persists even if the container is stopped or deleted. The environment directive is used to set environment variables in the DB service. Here, we're setting the root password for MySQL, the database name, the database user, and the user's password. These environment variables are used to configure the MySQL server inside the Docker container. Remember, you should replace MySQL_root_password, MySQL_database, MySQL_user, and MySQL_password with your own values for security purposes. Finally, we will define the volumes section in our Docker Compose file. We'll specify a volume named DB. In Docker, volumes are used for data persistence and sharing among containers. They are easy to back up or migrate and can be managed with Docker commands. By stating DB, we will be creating a volume named DB. This volume will be linked to our DB service, ensuring that our database data will be stored on the host machine and not lost even if the database container is removed. Once our Docker Compose.yml file is ready, we'll run the Docker Compose up-d command. However, you might notice that Docker is currently not running. If you are using a Mac OS or Windows system, it's necessary to launch the Docker desktop application to get Docker up and running. As for Linux users, Docker runs as a service on your machine. This means you'll need to start it as you would any other system service. Next, let's use the Docker Compose up-d command again. This command will initiate and run our Docker containers. We can see the status of our Docker containers by running the Docker Compose ps command. Our index.php file will contain simple HTML and a PHP echo statement that says hello, Docker. When we run our Docker containers and visit our local server in the browser, we'll see this welcome message. To test our database service, we can log into the MySQL service inside the container. First, let's execute the docker compose exec db bash command to enter the MySQL container. Then, let's log into MySQL. Next, we will test our connection to the MySQL database. For this, let's create a new file named database.php. In this file, we'll add code specifically designed to test the connection to our MySQL database. Once the file is ready, we'll run it. While doing this, we'll encounter an error. The error message points out that the MySQLi class isn't found. This issue arises because the PHP Apache image, which is currently being used by our web service, doesn't include the MySQLi extension as part of its default configuration. To fix this, we'll make a Dockerfile in the docker/web directory. This Dockerfile will start with the PHP Apache image and install the MySQLi extension. Next, we change our Docker compose file. Our web service will no longer use the PHP Apache image directly. Instead, it will build from our new Docker file. We will first execute the docker compose down command to remove the existing containers. After that, we'll rebuild our containers using the newly updated image for our web service. Now, the web container includes the MySQLi extension. Finally, we can run the database.php file without any errors. Great, we've connected successfully. Now we're going to set up the PHPMyAdmin container in our Docker compose file. This lets us manage our databases more easily. Next, we'll use the docker compose upd command. This will start our new PHPMyAdmin container. When PMA arbitrary is set to 1, we must type in the server host each time. Instead, we can use PMA host in our Docker Compose file. This way, we won't need to type the host into the login form each time we log into PHPMyAdmin. Because we have updated the PHPMyAdmin container settings in our Docker Compose file, we need to first stop and remove this container. After that, we will start it up again. And there you have it, the server field is no longer displayed on the login form. This is because it's already configured to connect to our database container. That's it for our tutorial on setting up a PHP project with Docker, using the PHP Apache image and MySQL for our database. We also showed how to install the PHPMyAdmin container for easy database management. I hope this tutorial was helpful. I will see you in the next one.